This video will take you through the data analysis for the bean experiment that we did this week in lab. The first thing that you need to do is you need to go to your web browser, navigate to Moodle, log in. Once you've logged in, navigate to this week's lab, and you will see that I have updated the folder somewhat. I have the old beans dataset in there in case you're curious about anything, but beans.csv is the dataset that you guys generated in class, and we have the beans.r. You need to download beans.r and beans.csv and put them in a common folder on your computer somewhere. I have already done that, and I put my materials on my desktop in my Bio 357 materials folder in Lab Week 1, and you can see that there's beans.csv and there's beans.r. If you are just now using R for the first time, or you had to reinstall R, one of the things that you might want to do here at the beginning is right-click on beans.r, and if you're on a Mac, go to Get Info, and I forget what they call it. I think they call it Properties in a Windows environment. But go there and you will see a set of drop downs, and one of the drop downs that you will want to look at is the Open With drop down, and click on it to open things in RStudio, and then click the Change All to make sure that anytime you click on an R script, it's going to open it automatically in RStudio. The other thing that will make your life easier is if you have your script and your data file in the same place, then you don't have to go entering paths in your R script to tell it where to go and find your data. So once you have that all set up, you can just double click on beans.r, and it will open up the R script, and the R script I have modified since we were in lab. It should all be here for you. So the first thing that you want to do is you want to get the working directory. That's what getwd stands for. And you'll see the output is down here. So your script is in this upper left-hand corner window. The actual console where the script is being activated and run is down here in the lower left. You have a history and environment section here. You can see what all you've done in R, and you can see obviously I've done a lot and haven't cleaned out my history in a while, but it tells you stuff that you're working on. So when we upload the data file here in a little while, it will appear over here, and then this other lower right hand window is where our plots will appear. So it also shows us where our packages are and which ones are activated and whatnot. And you can see right now we have very little activated, but we're about to activate some packages. Now when you run getwd, it will show you down here what directory you are in, and you can see that I'm on my computer on the desktop in the Bio 357 folder, and within that folder I'm in Lab Week 1, which is exactly where I want to be because that's where my data are hanging out. Once you've verified that R is running from the directory where your data are found, you can then load the libraries. If you don't have these installed, you should have gotten a message up here at the top somewhere that says something along the lines of, this script requires these packages, do you want to install them? Just go ahead and click install, and that will actually install all of those, and then you can run the library command and it will load those. As you load those, you will see that ggplot2 over here was unchecked. Now it's checked because you told it to load the package ggplot2. Once you've done that, you want to read in the data file. That's what this command is essentially doing. It's telling you to read in a comma-separated values file. The name of that file is beans.csv, and we're going to just save this as a shorthand term dat. So anytime you write dat, it will basically go and get this data file. And so this little thing here, which is the less than sign and a dash, that's called the assignment operator. And what you're doing is you're assigning this action on the right to this shorthand name on the left. And so that's why it's called the assignment operator. So if you do that correctly, it should show that it is run down in this lower left-hand column or lower left-hand window. And what that signifies is that it ran it, and now it's just waiting for you to give it the next command. You can check to see if it read it in correctly by looking at the head, the first 6 lines of the data file. You can see that these are Mason's data and his first 6 trials. There is a column for student, there is a column for lot, there is a column for the unconscious selection, and there is a column for conscious selection. You can also do the tail of that data file, which will give you the last lines, which this are Elizabeth's data for her last 6 values. Or you can view the whole data set all together, and it opens it in a separate window, and you can see the whole thing. Let's close that because we are really interested in that. The next thing that we want to do is we want to check and make sure that it's treating these columns like we want them to be treated. We want lot to be treated as a number, unconscious selection to be treated as a number, and conscious selection to be treated as a number. So we can find this out by asking it what class of data. So class dat $lot, it's basically saying what is the class of data in the data frame dat in the column lot. And because these are all integers, 1, 2, 3, 4, 5, there's no decimals, it should tell us that it's treating those as integers. It will tell us numeric data for unconscious and numeric data for conscious because those are things with decimals. So we know that R is treating the data the way we want it to treat the data, so now we can just run a model. And what we're going to do is we're going to do a linear model. We're doing a linear regression of the unconscious selection data regressed on lot number. The data are found in the data frame dat, and it's just going to store this in model 1. Once again, we use the assignment operator to store this long bit of code so that we don't have to retype that over and over again. We can just type in model 1 and it will give us that thing. So let's run that, and then I'll show you when we type in model 1, it actually just tells us what we found. Well, we found that the intercept of this linear regression is 3.48695, and it tells us that the slope value is a negative 0.02. Unfortunately, it doesn't tell us anything else about the model, but we can get a summary of the model that gives us more information. And when we run the summary of the model, it basically tells us what the equation is. It's unconscious as it's described by lot. And then down here, it tells us what the y-intercept value is. It tells us what the slope is. It tells us if the y-intercept is different from a slope of 0. And it tells us if the slope is different from a slope of 0. So y-intercept is significantly different from a y-intercept of 0, and this slope, even though it's a small slope, is significantly different from a slope of 0. There are also other things that this output tells us. It tells us what the r-square value is. Remember that r-square value tells you the degree to which the x variable describes variation in the y variable. And so variation in x describes about 30% of the variation in y, which is not a particularly high value. Remember that r-square can range from 0 to 1, 0 where x doesn't explain anything about y, and 1 where x and y are basically the same. It gives you the F statistic that you would get from an ANOVA table. It tells you the degrees of freedom. We had 80 observations, so we have 78 degrees of freedom in the error. And it tells you the p-value, which is 1.878 times 10 to the minus 7. That's a very, very small, p-value. So when we go to plot this, what we should expect to see is we should expect to see a negatively sloped line, but it's not going to have a terribly steep slope, and there's going to be quite a lot of variation around that line because we have a relatively low r-square value. So this next block of code right here basically just generates a plot for us. We're basically going to plot the lot number on the X value, the lot size on the Y value, and that's in the column unconscious. We're going to fit a linear model to this, so it's going to plot the best fit line through the data. It's going to illustrate our data as points that are black with a white circle around them. We're going to limit our scale of the y-axis between 2 and 5 so that we can compare unconscious selection and conscious selection on the same scale. We're going to give the X label a title. We're going to give the Y label a title. We're going to give the graph as a whole a title. And then all of this is basically just formatting, controlling the sizes of fonts and whether or not they're grids in the plot and things like that. You can run all of this big block of data as a single line, just go anywhere inside of it and activate it. And what you see is exactly what we thought we would see when we looked at the results up here. We see a negatively sloped line. That slope is significantly different from a horizontal line, which would be a slope of 0. But we also see that the data are fairly variable around the line, which is why the R-square value is just 0.2955. So knowing the lot number, variation in lot number doesn't account for a ton of variation in lot mass. We can now do the same thing with the conscious selection data, the thing that you did twice. We're going to call this model 2, but it's just the same model as before, except that we're changing which column of data we're looking at. In this case, we're looking at the second column of data, which is the conscious. And what we find when we run that is, once again, the y-intercept is there. The slope value is negative, but you'll notice that it's now more negative than it was before. It has a steeper slope. It's a slope of negative 0.09. And also the level of significance is higher. You'll also notice that the R-square value is higher. Now in this case, variation in the x-axis explains about 90% of the variation in the y-axis. So that's a much higher R-square value than you had before. It gives you, once again, the F statistic, the degrees of freedom, and once again the p-value that was like 1.7 times 10 to the 7th or something like that. We can go back up and look actually. 1.87 times 10 to the minus 7th. This is now 2 times 10 to the minus 16th. So it's a much lower p-value. We're going to just copy the same plotting block that we had before and change the y variable to conscious selection versus unconscious selection. Once again, we're limiting the y-axis so that we can compare these two plots directly. And when we run this block of code, what we get is exactly what we would expect, which is a steeper line. The early lots are higher in mass, and the lower plots are lower in mass, and the data are more tightly clustered around the line, which is all things that we should expect to see based on this output that we got from running the regression analysis, where the slope is steeper, but still negative, and the R-square value is higher, meaning that the X variable, variation in the X variable, is explaining considerably more variation in the Y variable than was the case in this case. The nice thing about plotting these things on the Y-axis, with the Y-axis having a constant scale, is you can flip back and forth between these two plots and see very quickly and easily the differences between the two plots. And ultimately, when we think about selection acting on a phenotypic trait, in this case the trait would be seed size, selection is going to proceed, evolution is going to proceed much faster under this type of selection than it does under this type of selection, because the selection is less strong in this case, and it also is not very consistent, as opposed to under conscious selection, selection is stronger and it is much more consistent. This relates directly to figure 1 from the Brody and Brody paper that is in the folder. Figure 1 shows you the effects of, describes the effects of selection when it's strong versus when it's weak, and when it's consistent versus when it is inconsistent. And so hopefully that will take you through this. Once you have these plots, you're going to want to get them into a form where you can put them in your lab report. So you can go to the export tab over here where the plot is. You can save this as a PDF or an image. I usually save this as a PDF because it preserves more of the details of it. It makes it a higher resolution image in a smaller sized file. And so I'm just going to call this unconscious so that I can go and find it again. And you can also check what the dimensions are going to be. So 8.5 by 11. So it's a standard size page, but it'll be kind of proportional to a page. And you can either click or unclick view the plot after saving. I always like to view it right after I save it, so I can come back and change anything in here if I don't like the way it looks. When we save that, what it will do is it will give us a PDF of the data, and you can see it's unconscious selection because the title is up there, lot mass versus lot number. This is the unconscious selection because you see that the slope is relatively shallow and the variability around the line is relatively high. You can do the same thing for the conscious selection, export it as a PDF, call it conscious, and once again spelling conscious correctly. And when you save it, it will once again save it in the same way. You can then paste this into your lab report, and you'll have a figure for explaining what the results of your experiment was. Here's the unconscious selection, here's the conscious selection. Once again, they're on the same Y scale, so it makes it easy to see differences between them. All right, so that is that. Let me know in class tomorrow if you have any questions about that. And certainly let me know if you're having trouble getting R reinstalled on your computers, or if you have it installed on your computer and you're just having trouble remembering how to operate it and things like this. I'll be happy to help you out with R-related issues. If you haven't been around it in a little while, it can take a little bit to get back up to speed and feeling comfortable with it again. So let me know if you have questions, but that's pretty much it.